This is a Mitsubishi Lancer Evolution 4 body. Once it's stripped like this, it feels very honest. We're not distracted by trim, paint or badges anymore. We're just looking at structure. We start noticing where the car feels solid and where it doesn't. We can see where things line up in a way that feels intentional and where the structure clearly wasn't meant to carry much load on its own.
Just with the roll cage, basically, that it has to be 6 points. The wall thickness can't be less than 2.6 mils. You can't have bends smaller than 3 times the diameter of the pipe. That's pretty much the gist of it.
Well, of course, we planned the roll cage on paper, but the shell had other opinions.
Because attempt number 1 was a failure and attempt number 2 was a mathematical failure from my side, we're just trying to make 100% sure that we can get it tighter, because I noticed that there was quite a bit of a gap on the side, which would be fine, but I want the cage to sit incredibly tight. So this is the main die that fits the pipe, that is the same, that the pipe actually manually bends around, and then this is the follower, which makes sure that the pipe doesn't crush, so that it just follows the die. It's like the follower basically. And then this arm turns the die. This is the, can you say, the fulcrum point to push against this arm to make sure that it can bend.
Now, once we settled in, there was a rhythm to it. Measure, bend, test fit, adjust, and repeat. We were not trying to rush through this, but we were trying to get the tubes to sit where we thought it made sense.
We got to kind of get the main hoop in its place, so that'll be our datum point. So we're going to bend our pipes and put all our other pipes off this, running to the front and running to the back. So we kind of want to get this done, build the boxes for here on either side, tack this in place, keep it there so that we can run everything else off this.
As more of the cage went in, the shells started feeling a bit different. Not in a dramatic way, but in small, noticeable ways. There wasn't a single point where everything suddenly changed. It was just built gradually as more structure goes in and things started working together. This kind of work feels especially natural in an Evo shell, because Mitsubishi didn't stumble into performance cars. Long before rally stages and homologation specials, the company was building ships, aircraft, trains, and heavy machinery. That meant dealing with vibration, fatigue, and repeated stress as part of everyday work. We could feel some of that background when we were working on the shell. The structure felt considered, and nothing looked like it was done just to impress someone standing still. So adding a roll cage didn't feel like forcing something new into the car. It felt like continuing a line of thinking that was already there. When we talk about Mitsubishi, we're really talking about how Japan learned to work with steel at scale without losing the mindset that came from working it by hand. For a long time in Japan, steelwork was very hands-on. Sword makers worked in small workshops with family names attached to the work, and those same families often did the same thing for decades, sometimes even across generations. They learned early on that steel remembers what you do to it. How it's heated, how it's cooled, how it's worked, all of that stays in the material. What made that difficult was that mistakes didn't always show up immediately. Something could look fine and still fail much later. So the focus was always on structure first and shortcuts last. That's the world Yataro Iwasaki was born into in 1835. He came from a samurai family, but by the time he was growing up, that status didn't mean much anymore. His family had been reduced to farming. The name was still there, but the system behind it was collapsing. When Japan was forced open to the world in 1853, the feudal system fell apart very quickly. Samurais lost their income and their role in society, so most didn't know what to do next. Iwasaki reacted differently. He challenged corruption in his local government and ended up in jail for it. But while he was there, he studied under a reformer named Toyo Yoshida, who believed Japan had no choice but to industrialize if it wanted to survive in a world dominated by Western powers. Iwasaki took over a small shipping company owned by the Tosa clan in 1873 and renamed it Mitsubishi. By the late 1800s, Mitsubishi was building modern steel ships, running coal mines, operating heavy machinery, and laying the groundwork for Japan's industrial base. They never chased trends, but they moved logically from ships to machines to engines to aircraft because all of it relied on understanding structure, materials, and systems. Even the logo reflects that thinking. The three diamonds came from two family crests. One comes from the Tosa clan's three-leaf design, and the other comes from the Iwasaki family's three stacked diamond shapes. This represented balance, responsibility, and strength through structure. That thinking carried forward into everything Mitsubishi built later, including cars. So when we're standing here now, measuring, bending, and fitting steel into an Evo shell, we're not doing something separate from that history. We're working inside the same logic that built ships, engines, aircraft, and machines. Understand the metal, control how forces move through it, and deal with the structure before asking anything else of it.
So what a gusset is, it's like a plate that you weld in to strengthen two or more joints. So two pipes that are going in like this, so it doesn't flex. So David came with a really good idea, just to make it look different. I was going to dimple dye this triangular shape to give it a step, like a speed hole. So what happens is you cause like a strengthening spot in the steel, but what we're going to do here is, instead of doing that, we're going to cut this out on either side, and then we're going to weld a plate in so you can look right through it.
Now coming back to the car towards the end of the phase, things felt different. There was less measuring, less standing around and trying to picture things in our heads, and most of the big decisions were already behind us. Now it was just about consistency.
We're going to make a triangle that fits in there like that, and then we're going to weld it in. So you can't see the pipe from there. It'll just look like it was made like that.
We are making sure the left and the right sides match properly, making sure nothing is fighting the shell, and cleaning up details that only really matter once everything else is in place.
Because the cage is mounted in 6 points, the chassis can still, and they're not connected, it means that the chassis can still flex a little bit around the cage and vice versa. But once you start welding all these gussets in and stuff, you're making it one.
The cage doesn't dominate the space, it just fits. Inside, the car feels more deliberate now, not cramped and not aggressive, just purposeful. And that's why we started here. Not for the visuals or the noise, just because once this part is done properly, the rest of the build becomes easier to understand and harder to cheat.